Thank you, Mustapha, for your. Thank you very much for this nice and interesting presentation. So now we can now move to the discussion session. Look, I ask all the participants if they have some questions. Now on this site there is, I think, 2 questions available on the site. No. Is the first question. Okay, the first question is from Samir. Samir said, can you please provide some insights on the relative main or aftershock activity after the main shock of this earthquake? No strong aftershock were so far recorded, and we know that no minor
I don't hear Samir. Samir is talking?
Yeah, Samir Blabbas, no? He's on.
Hi, Mustapha.
Hi.
Okay. So you
Hi.
can ask.
Yeah, hi, Mustapha. Thank you very much for the very insightful presentation that you gave here. So the question is mainly about this relatively small aftershocks activity and the relative minor aftershocks that we were feeling after the main shock of the 8th September earthquake. And then we had really minor aftershocks that caused very minor damage. So I don't know if you have any explanation on this observation that you have already mentioned during your presentation. Thank you very much.
Yes, thank you, Samir. This is a very good observation, because if you try to take the aftershocks so far, I mean, this is only 10 days after the main shock. If you take the aftershocks and try to adopt apply the Omori law, so you will have a gap between the main aftershock, who is 4.9, and it took, I think, the same day, the same 24 hours, I think, on the 9th September. And since then, there has been no larger aftershock in this area. While if you do the comparison with the Boumerdès earthquake, and you know this because you did some work on that earthquake, we noticed that the aftershock during the Boumerdès magnitude 6.8, so it's comparable, and it's also reverse faulting. The main shock, the main aftershocks they were larger. They were larger. So what's happening here? Is it that some seismic energy is missing, and then it will be released, or is this just a characteristic of the High Atlas Mountain? I don't know. Frankly speaking, I don't know. I'm just puzzled by the fact that there has been no very large aftershock after the 6.8 of the 8th September.
Thank you very much.
You're welcome.
Okay, is there another question, please?
I saw a written question about the reliability of the 852 and I go 55 return period.
Return period, yes.
Yes.
Question from Mohammed.
This is from Azal Arab, yes.
Yeah.
And this is, I said it's a speculation from our part.
Yeah.
I'm not saying that this is really has to be reliable. I made a comparison with the mosque, with the Kutubiyya mosque in Marrakesh, who was not destroyed by any earthquake in the past since its construction in 1158, and but it was damaged during the 8th September 2023. There are videos and observation that shows that the tower was shaken. So if the tower was shaken and damaged during this 2023 earthquake, and it was not, and I'm very carefully saying this, and supposedly it was not damaged during the past, in the past, since its constructions. It means that the return period of earthquakes or large earthquakes and damaging earthquakes in this area is about more than 800 years. So this is all what I'm saying. Maybe other investigations should be done. At the beginning, I have shown that the area, for example, was affected by 1719 earthquake and also 1783 earthquake. But this is what I'm questioning. Maybe those earthquakes they were not large enough.
Yeah.
So this is the thing. But the correlation between the return period of more than 800 years and the 0.5 to 1 millimeter shortening rate in this area, it is very, very
correlative.
Can be correlated, yes, because we have a low rate of active deformation anyway.
And maybe Mustafa, the second question of Az Al-Arab, no? Concerning the symmetrical damage are not symmetrical around the epicenter. What is the scientific reason for this?
Can you repeat? I didn't understand what you said.
Yeah, he said the damage are not symmetrical around the epicenter. What is the scientific reason for this? For Mohammed Az Al-Arab, no?
Yes. Well, we know that this area is the earthquake is partly in the High Atlas Mountain, and another one is in the basin, the sedimentary basin to the north, which is, I think, named the Al-Haus. Sorry, Al-Haus area. So it depends on the geology, on the geological background.
Yeah, I think.
If you are in a region, we have many villages.
So it is related to topographic effect.
Yes, well, topographic effect. Yes, topographic.
Maybe the activity of the fault.
The activity, I don't know, and this has to be investigated. I don't know about the activity, but this is a thrust fault. This is not a strike slip fault. This is a thrust fault.
Thrust fault.
Yeah.
And maybe also the existence of the basin to the south, no?
Yes, for example, Tarudant, which is a village to the south, but it is in the sedimentary region. Suffered very much from the damage. So maybe this is also the distribution of the geology, but also the topography and the landscape influence the damage distribution.
Okay, another question from Professor Beljoudi, who is director of CRAT, no? Hamoud.
Thank you, Said.
You're welcome, my friend.
Thank you. Good morning, everybody. Good morning, Mustafa. Thank you.
Good morning, Hamoud.
For your presentation.
Thank you.
I have just a question. Can we talk now maybe about starting of an era of seismic activity in the Tel Atlas? The Tel Atlas now extend until Algeria and maybe until with the fault of Gafsa in Tunisia. Maybe can we talk that now we are in a new episode, a seismic episode for this contact, for this chain of a big fault with the earthquake of 8 September 1923. Thank you, Mustafa.
Okay. This is a good question, because since the last let's say 10-20 years, we have seen that several earthquakes took place in the Maghreb region. Okay. And including Tunisia, in Algeria, in Morocco. In Algeria, it was since the Ain Temushent and also the Boumerdès earthquake, then Al Husayma, then has been maybe not damaging and but in the desert, a 5.9 earthquake in Tunisia, in the southern Atlas, next to the Sutter zone. Can we say that this is an onset of a new era? I don't know. I don't know. Frankly speaking, I don't know. We need to maybe do an investigation on historical earthquakes, and then also take the instrumental earthquakes and look after all the earthquakes that took place in the last maybe century, and compare. What is important here, and I said it several times, is just the rate of active deformation. The rate of active deformation in the Maghreb region shows that some earthquakes, they have a long period of time, return period, simply because the rate of active deformation is very low. And but this is at one situation, one place, but doesn't mean that all along the atlas the return period is few centuries, eight centuries, maybe 1,000 years, things like that. So that's why I think because the earthquake area has more than nearly 2,000 kilometers long, for example, from Morocco to Tunisia. So this may show that earthquakes they may take place, and then we have the impression that there is an increase in the frequency. But if we take each active fault, we will figure out that there is no increase in the frequency itself along a single fault itself.
Okay, Mustapha. There is other questions, no? Maybe a question from Dr. Haytham. Are you here? Dr. Haytham?
Yes. Assalamu alaikum.
Okay.
I'm here, Dr. Saeed.
Hazm and Naili, we are coming for you, no? To you, no? Okay, Haytham.
Thank you.
It's
Yes.
for you.
So, thank you very much, Professor Meghraoui, for this insightful presentation. So I have mainly two questions. So in light of the recent earthquakes on September 8, 2023, could you elaborate on the potential implication and recommendations for seismic risk mitigation in the high Atlas seismic zone? So also, how can the broader geoscience community contribute to addressing these challenges? Also, are there any emerging technologies or methodologies that hold a great potential in advancing our understanding of seismic hazard? And thank you very much.
Okay. Okay. Thank you for the question. The two questions. So they are dealing with the seismic risk rather than the seismic hazard. And the new technologies is going a little bit far away. The both questions, and I'm sorry to tell you that are a little bit away from my specialty. You see, I'm an earthquake geologist. I did some seismology and some structural geology, paleoseismology, and I'm a little bit far away from the seismic risk. And what I can say, and then I said it, that the shaking of the high Atlas is something maybe that is not very frequent. So in terms of seismic hazard and seismic risk, the local engineers they need to be very careful with any conclusion on the let's say the size of the constructions and the size of the buildings and dams and so on. So I think this is, let me say it differently. This is a new earthquake in a high mountain in the high Atlas, and I think the civil engineering and the engineering seismology they have to figure out a new way of studying the region for the seismic risk. So this is what I can say, because I'm coming from the seismic hazard rather than seismic risk.
Thank you, Mustapha, for the response. There is more question from the site before moving to Hazm. No, he said, "Is there any recourse of strong motion around this area, and maybe is there PGA monitoring? No, of value of the PGA."
I try to connect with our colleagues in Morocco, and I mentioned about Youssef Timulali, but also our Omar Ibn Ibrahim and Fida Medina, etc. They are very busy, of course. They are very busy with the damaged area. They're trying to investigate and things like that. I don't know, frankly speaking. I know there are many seismic stations, but strong motion stations, I don't know. And so this has to be the question has to be asked directly to our colleagues in Morocco. So I don't know. Yeah.
So Hazm Badruddin, Dr. Badruddin,
Yes.
you are here.
Yes. Thank you.
Salam.
Salam. Thank you, Prof. Mustafa, for your very nice presentation.
You're welcome. You're welcome, Hazm.
As from when Riyadh, no?
Yes, yeah. My question is regarding to the first slide. I'm asking about if it is possible for large earthquakes to generate rupture crossing many fault segment, or will be just limited to just one segment. Because when you presented the first slide, I found there are many segments for that fault.
Yes.
Because I'm asking that because some people using some empirical equation to estimate the MMX using fault length, fault area, and all of this stuff.
Yes.
Thank you.
Yeah. Thank you for the question. Interesting question. Well, you've seen, for example, in the high Atlas, the rupture zone is about 40 kilometers long, and it is stress fault. If I see other earthquakes on the same mechanism, example, the Agadir earthquake is only 10 kilometers long. The El Aslam is only about 40 kilometers long, and Boumerdès is also only 40 to 50 kilometers long. So the earthquakes, although you have the impression that there are very long faults, and they have many segments, and the question are they going to generate an earthquake larger than magnitude 7.5, maybe magnitude 8? I think this is excluded from my side, as long as I know how the earthquake are generated in these areas. But frankly speaking, since these regions are not studied in detail, I can say that we cannot exclude a 7.58 magnitude earthquake along the South Atlas rupture zone, because you have 200-300 kilometers long fault. So this cannot be excluded. So the people that they use the empirical relation between the fault length and the earthquakes, they can do this inference, but they have to prove that if you have a magnitude 8, 7.5 or 8, you need to have 5 meter minimum and maybe 10 meters of the slip, seismic slip, and this has never been observed in these areas. So one has to be very careful with this inferences from the fault length to the max in the Maghreb region, for instance.
So thank you, Mustapha. There is a question on the side from Dr. Professor Zakaria Hamimi. No, he say, may I have your attention, Mustapha, that the east-northeast or east-northeast oriented rivers fault is the right-handed transpositional fault zone or shear zone?
I don't understand the question really.
It's about is it transpositional fault or shear zone? I think that it's transpositional fault. It's the south
border. Fault is a shear zone.
Yeah, the fault is shear zone. Yeah.
Right. Yes.
But
so the transpression is the combination between strike slip fault and
Okay, so we move to the question from Munir, Dr. Naili.
Thank you, Said. Can you hear me?
Yeah. It's
yes.
okay.
Hi, Mustapha. It's always a pleasure to listen to your talk.
Hello, Munir, all the way from your place?
Canada.
From
Yeah,
Canada?
we're doing fine. Yeah,
From
we're
Canada?
still safe. Yeah, from Canada. Yeah.
From Toronto or Ottawa? I don't remember. Yes.
Yeah, from Toronto. Yeah, Mustapha.
Nice to hear from you.
Thank you, Mustapha. So, Mustapha, it was a pleasure listening to you. You know, I'm electrical engineer and with quite interest in earthquake seismology. And as far as I understood, this is maybe the largest earthquake since the Agadir one in 1960, right?
Yes, definitely.
So it is. Can we qualify this as quietness spirit of the earthquake?
I didn't hear very much. Can you repeat the question?
Can you qualify this as quietness spirit from 1960 up to now? There is no activities, such activities in that area. And because
Yes.
I'm trying to reflect on what we might expect in Shelif area. So we didn't have any earthquakes since 1980, and
Yes.
I know that you have been very much involved, working
Yes.
a lot on that area.
Yes.
So what we might expect during this quietness period? And what would be the implication of the seismic
Yeah.
hazard
Yes,
all this?
Munir. Any question dealing with the prevision and prediction? It's very difficult. It's very
Absolutely.
difficult to answer. Yes. What I can say is this region, either the High Atlas or maybe even the El Asnam area, they're not. We're not along the San Andreas here. We're not along the North Anatolian Fault. We're not along the fault in China or the fault in Iran.
Absolutely.
These are regions with a very low rate of active deformation. When I say very low, it's less than 1 millimeter per year.
Yeah.
So less than 1 millimeter per year, it means that it's maybe 1 meter every 1,000 years. Okay, so anything dealing with the let's say stress transfer or the correlation between one earthquake and the other, it is very difficult. It's very difficult, simply because not only because the rate is very low, so we cannot. Is that these regions are not enough studied. You see, if you count the number of PhD studies and field work with all the equipment, like say seismic profiles and boreholes and measurement of strain and it's very there's very little work done in this region. There are some work on geology, of course, but on active faulting and active deformation and earthquake geology, it's very little. So we cannot speculate much on and give a prediction or a predictive and value on things like that. Already here, when I putting, I hesitated very much to mention about this return period larger than 865 years, because this is really a speculation that I'm making. And I hope that the people that are hearing this presentation, they understand the intention, my intention in giving this speculation, because this needs to be confirmed, studied, and having a little more work in deep. So this is what I can say, Munir. I hope I answered your question.
Thank you, Mustapha, for the clarification. So Mohamdi Yahya. Mohamdi is also
thank you,
is the heart of this webinar, no?
He's the boss.
Yeah, he's the boss. He's the boss.
Okay, thank you, Mr. Meghraoui, for your insightful presentation.
You're welcome.
It was a pleasure to hear you here.
You're welcome.
I would like to ask a question which is a continuity of a question asked by Mr. Beljoudi about the continuity of the seismicity through the Saharan Atlas part.
Yes.
In your first map, you have shown that this fault zone of from Gafsa to Agadir is a long fault zone. I would like to ask, at the best of your knowledge, is there any differences at a seismotectonic point of view or geologic structure between the High Atlas, the Moroccan High Atlas, and the Algerian High Atlas, and the likelihood of the occurrence of such event in the Algerian part?
Yes. Okay. This is how can I say? I mean, now because of the Agadir earthquake and the Adasil earthquake, so in the High Atlas, of the 8th September, we are beginning to understand a little bit more about this South Atlas front that I'm showing now. Okay, and then if you continue the mapping, you saw that this South Atlas front goes to the Sahara Atlas in Algeria, and then goes to the Southern Atlas active folding in southern Tunisia. And I can tell you that the fault exists everywhere, and it is affecting quaternary units. It is affecting Holocene and Pleistocene units. So going from here, from the observation on the faulting and doing inferences for the earthquakes, it is a step that is difficult for me to go and because in the High Atlas here we do have Agadir and the recent 8th September earthquake. There are some minor earthquakes also, they took place, but these are five magnitude earthquakes. In southern Algeria, in the Sahara Atlas, the same. There has been some 5 magnitude earthquakes and damaging earthquakes. I mentioned about the 1863, I think, 67 earthquake that destroyed the city of Biskra. And in the southern Tunisia, the same. So can we say that the same activity may happen all along the Atlas, the Sahara Atlas and the High Atlas, as it is happening in the High Atlas? This question, as I said, I cannot answer. I cannot answer simply because we need more work, we need more investigation, we need more PhD thesis, we need more master degree thesis, we need more, maybe even more seismic stations along these regions. It is very difficult, as I said, because the rate of active deformation is very low, and how can we cannot speculate, we cannot infer that a large earthquake may happen in these regions if we don't see the seismicity. We don't control the daily seismicity day by day to understand how the seismic energy is released in these areas. So that's all what I can say. For the mechanism is the same mechanism and all along.
Mr. Meghraoui, just a remark. If we look at the topography of the High Atlas Mountains, as you mentioned, it's very high compared to our Saharan Atlas. Could we say that this higher topography is due to more activity within the Moroccan side?
Yes, definitely. You have 4,100 meters in the High Atlas in Morocco, but still you have 2,300 meters in the Ores Mountain here, right next to the South Atlas Setter zone. So 2,300 and 4,100. It is comparable. It is comparable. So the topography is of course a result of the active deformation. And we can say that in the past, perhaps the atlas in Morocco was more active than the other part of the of the atlas in Algeria or in Tunisia. But it may mean that since we reached 4,000 meters in the high atlas in Morocco, so when are we going to reach 4,000 meters in the Sahara Atlas in Algeria and Tunisia? This is a question. So there is no reason why there is this such a difference. It means that you need more activity, you need more active deformation in southern Algeria and southern Tunisia, perhaps.
Thank you, Mustapha,
Thank you.
for this the response. So Mustapha, it's okay. Now we can continue with 2 or 3 questions. No.
Yes. Okay.
Okay.
That's
Okay.
okay.
Yeah. Okay. So Dr. Shakir. واضح Shakir.
Hello, thank you very much for your invitation for this very
you are
important lecture, and thank you, Dr. Mustapha, for this informative information. My question is about the probability of accidents, and was it expected to have an earthquake with this magnitude in this precise location? Also, what is your recommendations about updating the PGA, peak ground acceleration maps, zoning maps, or engineering seismology reasons, and also how to update the seismic code for building near these faulting zones? I am from Iraq actually, and also we have Zagros fault belt and the Anatolian belt. So what is your recommendations about taking the precautions when just finding the code, the seismic code?
Okay.
Yes.
Okay.
Thank you.
Listen, my recommendation is that the engineers, the engineering seismology, they have absolutely to integrate the earthquake geology data into their calculation of the, as you said, the exceedance, the probability of exceedance, and also the Mmax and the return period of larger earthquakes. In many studies that I have seen on seismic risk, I have seen really a deficiency in the earthquake catalog, because the earthquake catalog is very, in most cases, limited to the instrumental seismicity. It means the recorded seismicity, and sometimes in historical seismicity, but it's very, very limited. But there is very few regions where the faulting parameters and the return period taken from the paleoseismology, for instance, is taken into account, except, for instance, some regions like California, where the local institutions it is compulsory to take into account the paleoseismology. Even the atomic energy in Vienna in their recommendation regulations, they put there's compulsory the studies in paleoseismology linked to the seismic hazard and seismic risk. So you in Iraq, I think you have many faults there, and then I think there is a possibility to study those faults and to include the data taken from the active faulting for the seismic hazard assessment. And you have to tell to your engineers to be very careful with the historical catalog and instrumental catalog, because if the time window is not very large enough, you may miss a large earthquake and then underestimate the hazard and risk.
Thank you, Mustapha.
Thank you very much, Professor.
Thank you, Dr. Shakir. Dr. Masdouk.
Okay, thank you, Dr. Mustapha, for this nice presentation, and I am very happy to see you. My question is about what are the lessons that can we benefit or learn from this earthquake?
Well, I put it somehow in my conclusion. I can go to the conclusions here, and sorry, yes, okay. What can we learn from this? And this is a very good question. Thank you. We learned that in some cases we don't have much data and much knowledge on some regions. No, not because they were not studied from the classical geology point of view or from classical geophysics, but we are not taking much attention on some regions. After the 1960 earthquake in Agadir, it became clear for people working in seismology, seismotectonics, earthquake geology, that sooner or later there will be other earthquakes along the South Atlas setter zone, and either in Morocco, Algeria, or Tunisia, and some detailed studies are needed in these regions. So I go again in saying that we don't know much about our faulting, our earthquake area, and we need to do the field investigations with the new techniques. For example, there's a new technique, a new methodology that is now studied more and more. Is the time series of INSAR. Time series in INSAR is different than the INSAR for seismic deformation. It means that you take the images that are given freely from the European Space Agency, and then you study a region and you see how is the rate of deformation typically of that region, and maybe from that one, combined with the GPS, you can perhaps say, okay, this region may generate large earthquakes in the near future. So this is we have to be modest, and it seems that we know much about our regions and our earthquake activity in our regions, but this is not true. This is not true. We don't know much. We need more studies, more PhDs, more detailed studies in our regions.
Thank you very much.
Okay, Said.
Okay, thank you, Dr. Masdouk. Now, maybe I have here some small question from the website. No, the first one's coming from Fauzi. He say the value of the return period is obtained from a deterministic method, or we can say it's like expert opinion or judgment, because this value is very, very interesting, you know.
Yeah. Okay. Who is Fauzi? Which Fauzi is this one?
If we have to talk about this value, Fauzi Belalam.
The other boss. The other boss. The other boss.
The other boss. No.
Yes.
He's blind here. No.
Yes.
He's like false.
Yes. Well, as I said it, I mean the return period that I give here, larger than 865 years, is speculative. It's speculative, but this is science. I mean, in science, you can speculate, you can put a hypothesis, and then after work on it. and when I put this value of return period larger than 865 years is next to the rezoning that I made on El Kutubiyya tower and minaret and mosque that was not supposedly was not affected by any earthquake since its construction, since 1158 until 2023. So it's more than 800 years. So it means that here, can we say that the return period is of large earthquake, a larger damaging earthquake in High Atlas and Inner High Atlas, and then affected Marrakesh is about 860 years. So this is a question. This is more a question than an affirmation or something that based on detailed work. So this is what we can say. But making speculations and hypotheses and questions is part of the science, and this is how science goes forward.
Okay. Yes, Judy.
Oui, oui.
Ok, mon frère. Ok.
Merci.
It's
Juste
for you.
une dernière question, c'est thank you, Mustapha, and sorry to ask a second question.
Yeah, the second question. No?
Yeah, yes.
You're welcome. You're welcome, Hamoud. You're welcome. You're very welcome.
Thank you, Mustapha. Thank you, Mustapha. But as you know, actually in the social media, there are a lot of maybe in talks, a lot of information, fake information, true information. I don't know. But after the earthquake of Syria, Turkey, and now after the earthquake of Morocco, I want to talk about the Netherlands researcher, okay, which it's really maybe it talk about next earthquake, and in terms of prediction, we know as seismologists, this is a big challenge. This is a big challenge for seismologists researcher, and I just discuss. I don't believe it. I don't. But we want to discuss about this problem and how to talk with population, with Algerian citizen, which believe us to this kind of information. And this is my question, Mustapha. It's not scientific, but it's for the social. You know why? Because in CRAD we have also to talk with our population in case of earthquakes, big, moderate, of low earthquake. We need to give some explanation to re-answer them. Thank you, Mustapha.
Okay. This is a trap. This is a trap question. A trap question. Yeah. Okay. Yes. Okay. Yes, I heard, and I received many messages saying, "What do you think about this this guy from Holland? He's working in astronomy, and he's saying that because of this planet and this planet, so there is an increase of earthquake, and there will be an earthquake next Saturday or next Sunday. I don't know, and this like okay, these are kind of interventions that the people they do it very often, but very often after the occurrence of earthquakes. After the occurrence of earthquakes, this guy, he says that he could predict the occurrence of earthquakes well before, and he said that in the Mediterranean zone there will be large earthquakes and so on and things like that. But this has no physical or no scientific basis. I repeat, exactly. No physical or no scientific basis. So the population, they have to know that these people are charlatans. Yeah. They okay. The question, if the planets really are responsible of earthquakes, why the planets will be responsible only an earthquake in Morocco, in one place, in one situation? Why not in the Alps? Why not in the Zagros Mountains or in other mountains around the world? So this is not this is fake news, and really I say to the people that have some knowledge that this is not acceptable, and this is not the other things that also I heard, and this is really a deformation of our religions, our religion that we embrace and that we like. Some people they go for combining their attitude with God, with Allah, and saying that this is a how do you say, iqab, a punishment from Allah. So this guy who is saying this, even if he's imam or whatever, he's musharik. It means that he's putting his words with the word of Allah, saying that this is iqab. Iqab of what? Who asked you? Who put you on earth to say that this is iqab? In the past, there is a famous imam, Jalaluddin Sayuti from Cairo, and there was an earthquake, a large earthquake that affected Cairo at that time, and the people they kept saying the same thing. So Imam Sayuti he said stop this fake news, stop this excuse me for the word, but stop this bullshit news that you are expanding. This is the earth. The earth is alive. The earth is alive, and you don't have to correlate this fake news of iqab, of punishment from God, from Allah, to the local population. So the people has to be very how to say aware about these kind of fake news. So be careful.
Thank you, Mustapha.
That's it, Hamoud. I hope I answered the trap question.
Yeah. Okay. So before to close this this webinar, I would like to say thank you very much, Mustapha, for this fruitful presentation and discussion.
Thank you.
Thank you also to all the participants and all those who helped us to make this webinar a success.
Yes.
No.
Yes.
I know there were more than 150 participants. No, it's important. So I give now the floor to Mohamdi to add maybe a few words before close the webinar. Mohamdi. Yahya.
Okay, thank you, Mr. Meghraoui, for orienting this webinar, and thank you again for Mr. Meghraoui. I would like at the end of this meeting to express our sincere gratitude to all individuals who have contributed to this success, and in particular our people in Johazard Community Group and Jolion Hub platforms. In particular, I would like to extend our gratitude to Dr. Dinar Haytham, professor at the University of Batna, for his invaluable technical support, and also for Tizrawi Abdelrazak and Amar Balik, from researchers from CRAG, for their valuable contributions and support. I would like also to thank Miss Yella Samira, a master student from University of Sétif, for her significant contribution in preparing our introductory video. We also want to express our appreciation to all participants to their active presence and contribution. So don't forget to fill out the form. There is a form that we will share through our platforms to get a signed certificate from the head session, Mr. Meghraoui, and keep in touch within our platforms for further meetings and webinars. Thank you a lot, and salam alaikum.
Hello.
Thank you.
Now it's
Thank you
okay.
very much.
Thank you very much, Mustafa.
Thank you, Said. Thank you,
Thank you.
Mohammed. Thank you, Mohammed.
Thanks.
Bye
Ciao,
bye.
ciao.
Bye bye.